All right, so this is going to be the review for our test number 8 this Thursday, and this was the review we'll be doing in class, and this will be counted as your homework grade for the week. So if you see here, it says homework, but it's our test review as well, so it's a double whammy. So this week in class, we've learned a lot of things that are kind of messy, so we're going to start and dive into how we're going to look at these ones. So if we have line, it says use the slope formula to prove that the slope of line JL is equal to the slope of PM. So we have two right triangles here. So we have a triangle here, and we have another triangle. Use another triangle right there. So we have two triangles, and they both have their hypotenuse, or they both share this line right here. So since they both share this line, we're trying to prove, we're using the slope formula to prove that this portion of our line, so line PM, is the same slope as line JL. So with that, remembering that our slope formula, M equals, draw your line, subtraction sign, and then we're going to have y2 minus y1 over x2 minus x1. Always remembering that y is on top, so this is the change in our y, because our y is our rise and our x is our run. Rising up and down, our y is up and down. Our running, left and right, our x's is left and right. So that means we're going to have to find the coordinate pair location of each of these points right here. So I might have to erase some of my points just so I can see them. So we have M located at negative, so we have -10. So always starting at the origin, coordinate pair start there, and we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our x is -10, and our y is going to be 1, 2, 3, 4, 5, 6, 7, 8. So -10, 8 for M. And then doing the same thing for J. So it looks like we're at -8 for our X and positive for our Y. Oh, sorry, not -8. -7, +4. For L, we have -4, 0, and P, we have -1, -4. So we have these two lines. So we have the two, so we have this associated with M and P, so line PM right there, or MP. We have this one, or these two, with line JL. So if I'm labeling these, I can have X1 and Y1, and this would be X2 and Y2. So for my, when I plug my formula in, I'll have Y2, which is -4, minus Y1, which is 8, X2, which is -1, and X1, which is -10. And then we have our line JL, so this is for PM, and this will be for JL. So if we have X1 and Y1, X2, Y2, so Y2 is 0, and Y1 is 4. X2 is negative 4, and x1 is a negative 7. So if we look at this, we're going to have negative 4 minus 8, which will be a negative 12, and negative 1 negative 1 minus a negative 10, so that's going to be negative 1 plus 10, which will be 9, positive 9. 0, and then over here we have 0 minus 4, which will be a negative 4, and negative 4 minus a negative 7, so that will be plus. Negative 4 plus 7 will give me a positive 3. So we have negative 4 over 3 and negative 12 over 9. But this, if I simplify this one, simplified, this one will also be negative 4 over 3. And then we have the slope of JL right here, and the slope of PM here, and then simplified at negative 4/3. So using our slope formula, we were able to see that both of these lines were equal. Okay. So this one says, Joseph ran a 6-mile race in 48 minutes. Which graph has a slope that best represents Joseph's average rate of speed during the race? So we have distance in miles as y, and we have time in minutes as x. So we have miles over time, because it's always y divided by x. So if we fill that in, we'll have 6 miles in 48 minutes. So if we were to simplify this, if we divide 6 by 6, we get 1. And if we divide 48 by 6, we get 8. So our simplified version of our slope, our rise is 1, our run is 8. So we're going to need to find the graph that has that same rise over run. So if we're going here, our rise is 1 and our run is our line would have to be here, but that's not correct. So again, these two look the same. So our rise would be 1, and then, but right here, that's not the correct one. On this one, we have a rise of 1 and a run of 1, 2, 3, 4, 5, 6, 7, 8. So it looks like that could be the correct answer. And just to make sure, we'll check J. So if I run 1 and rise 8, so this one's tricky because it is on the line, but the slope of this line is undefined, which is not. Undefined does not equal 1 over 8. So our answer would be G. So so that means he ran, in 8 minutes, he ran 1 mile. Okay, the table below shows a relationship between miles traveled and fuel in a car's tank. Write an equation to represent the data. So again, on this one, we're going to want to use our stat function, the stat button on your calculator. We could do it another way, but since we've learned that way on the calculator, you would push stat and then 5, enter, and this sets up your calculator first. And then after you make sure you have L1 and L2, you'll push, so to get L1, so you push stat, and then you push the number 1, and then you'll get L1 and L2, and you'll enter your numbers, and then you'll get stat, and then you'll go cursor over to calc, and then from there you'll push number 4, and then you'll push enter 5 times. And that will give you this answer here. You'll get y equals ax plus b. So a will be your slope and b will be your y-intercept. The other way we could make sure, we could look at this, we could look here, and when the y-intercept is, or when x is 0, y is 15, so that means our intercept is going to be, our y-intercept is going to be 15. And then we could use our slope formula to do, we could do 0, 15, and 10, 10, 14.6, and we could find our slope as well. We could do x1 and y1, x2 and y2, and we could find our slope that way, but in the calculator it would be quicker. Okay, going up here to determine if each graph shows a proportional relationship or not. So what we've learned in class is that a proportional relationship has to pass through the origin. So this one passes through the origin, whereas this one does not. So since this one is a straight line through the origin. And then this one doesn't go through the origin, so you can use that as your other example. All right, number 5, Mr. Bagford is ordering rope for his boat. The rope costs $3.75 per foot. Shipping is $20. Write a function that can be used to find y, the total amount for Mr. Bagford would pay for X feet of rope. So y is going to equal our cost, and x is going to equal our feet of rope. So if we have an equation, y equals mx plus b, m is going to be our slope, and b is going to be our y-intercept. So the y-intercept is never going to change, and that's something that here, so we have our constant, that $20 is going to stay the same, but the $3.75 is going to change based on the amount that he buys, the number of feet. Okay. Determine if each of the following represents y as a function of x. If not, explain why. So we're going to go ahead and look at our x values. Look at our x values. We have 5, 3, 4, and 2. So since we only have, so no x value repeats. So that is a good explanation here. We have 4, -3, 4, and -3. So we have 2 -3 and 2 -4s. So the only way that this would be okay, so this one is a function. The next one, so this is not, because we have 2 x values, so because 2x, or inputs, produce different outputs. So if we're looking at our functional machine, if we put a 4 in, we should always get 1. But we put a 4 in our machine and we got 5, so that can't be correct. And here we should get 2, but we got a 3. Okay, we're looking here. So we have a 9 going to a 3, a 7 going to a 21, 11 going to 121, and 45 going to negative. Sorry, I forgot to the negatives on there. But we have 4 different x values that all go to different y values, so we're okay. And here we have 2 is going to 5, and 2 is also going to 20. So we have a 2 that is really, we have 2 different 2's going to 2 different y's. So we have separate inputs. So we have, since 2 repeats, so we have a 2, we really have 2 sets of 2's, so that would be repeating, and that would make it not a function. So here we have graphs, and so we're going to be looking at the vertical line test. So we have to, if we did, let's look at, if we're looking at a vertical line test, let's look. So if we're looking at this vertical line test, so meaning that it can only pass our graph at one instance. So if we slide this across, so if we were to do that, we would determine if this was a function or not. So since our graph only touched at one point, this is a function. So let's take our thing here. So remembering that we're only allowed to, our vertical line is only allowed to touch the graph at one point. So right here it looks like we already run into a problem because we have it touching in 2 spots. So this one would not be a function because we have a repeating x value. So let's try this on our last one. So if we take this across, so right here it seems like it's not okay because look, once we get to again, we have it touching in 2 places. All right. So here we have what is the slope of ST, of line ST. So line ST. So easy, we can do a rise, 1, 2, 3, 4, 5. So we have a rise of 5 over a run of 1, 2, 3, 4, 5, 6. And that doesn't simplify, so that will be our slope. But here, it's saying what is the length of ST. So if we wanted to know the length, I'm going to zoom in. The length of this, so counting, so this does not equal 1. So we can't just count. We have to, since we have a right triangle, we can use the Pythagorean theorem. So we have a squared plus b squared equals c squared. So knowing that our right angle points to C, so this would be A, B, and C, or the hypotenuse, another word. So if we have plugged these in, so we have 5 squared plus 6 squared equals C squared. So we have 25 plus 36 equals C squared. 25 plus 36 is 61. That equals C squared. And then in order to unsquare, in order to remove that square, we have to take the square root of both sides. And then the square root of C equals the square root of 61. And when you plug that in your calculator, you'll get a decimal here. All right, this is my favorite here. We're going to solve some equations. So draw our line down the middle, and we have to first get our like terms together. So we need to circle our constants and box our variables, right? So we need to get our boxes together and we need to get our circles together. So I'm going to start by moving my least variable. So this is going to be my least variable. So I'm going to subtract 6x from this side. So this will become 0, and I'll be left with 2 equals 3x minus 7. So then I'm going to get my constants together. 2 plus 7 is 9 equals 3x. And then our last step is to divide. And this becomes 1, and we'll be left with x equals 3. So here we go. So we're going to box our variables and circle our constants, box our variables and circle our constants. So we're going to move our least variable, since we don't have to combine any like terms. This will become 0. We'll be left with 5 equals 12 minus 8 is 4x minus 25. And then getting our constant numbers together, plus 25. So 25 plus 5 is 30. And 30 equals 4x. Divide both sides by 4. And we'll be left with x equals 15 over 2. And you could also write that as a decimal. All right, number 10. A fish tank is being filled with water as shown in the graph. So after 8 minutes, how deep will the water be? So right here, it shows that at 0 minutes, so at 0 minutes, it will be 4 centimeters deep. So if we want to look at where 8 minutes, so at 8 minutes, how deep will our water be? So at 8 minutes, we have 24 centimeters deep. So just being able to read that graph and looking at the different intervals. So knowing this is 4, 8, 12, 16, 20, and 24. All right. Oh, we have more on this one. Okay. So now we need to find, so now it's saying to find the slope. So we have a pretty point here and we have a pretty point here, so we could use those two. And it looks like, as I'm scanning this line, those are the only 2 pretty points available. So we have a rise of, so this is remembering that they're going by 4, so it's 4, 8, 12, 16, 20. So my rise is 20. And my run is, and here they're just going by ones too. On the x-axis going by ones. 6, 7. So we're going over 1, 2, 3, 4, 5, 6, 7, 8. 20 over 8, which will simplify to, we'll go to 10 over 4, which would also simplify to 5 over 2. 5 over 2. And our y-intercept is where our graph intercepts the y-axis, which would be at positive 4. So our equation would then read 5 over 2x plus 4. What does the slope mean in the context of this problem? So the slope of this line here is how deep the water is each minute. And what does the y-intercept mean in the context of this problem? So this would be the starting depth of the fish tank. Okay. So number 11, 2 customers took out loans from the bank. So we have autumn and we have summer, like the seasons. So we have a 4-year loan for $4,000 and paid 3.8 annual simple interest. And some are taking out a 6-year loan for $4,000 and paying 3.2 simple interest. What is the difference between the amount of interest autumn and summer paid for their loans? So we're looking at simple interest. We're looking at simple and simple, meaning we have I equals PRT and I equals PRT. So we have time, we have a principal, and we have a rate. We have time, we have a principal, and we have a rate. So we're going to be multiplying the principal times the rate times the time. So remembering that we have to divide our percentage by 100. So if we're to divide 3.8%, and we're going to have to turn that into a decimal, so 0.038 and 0.032. So we're going to be I equals principal 4,000 times rate 0.038 times 4. And we have 4,000 again for my principal times 0.032 and times 6. So the difference, so once you figure out, looking at the difference between those two here, once you multiply them, and the table below shows the amount of water flowing over a dam. So first the question is the relation proportional? Why or why not? So in order for it to be proportional, my x and my y, each y divided by x has to equal each y divided by x. Has to equal each y divided by x. So for here, my 4 divided by 3, is that equal to 8 divided by 6? So if I multiply by 2, we're okay. So to get to here, we're good. So now we have 12 over 9. So and is that equal to 16 over 12? Is that equal to 20 over 15? So looking at this, four divided by 3 and 8 divided by 6 and 12 divided by 9 and 16 divided by 12 and 20 divided by 15. So when you divide each of these, you end up getting each of these numbers simplify to 4, so they all simplify to 4 over 3. So each has the same k. So we did that, the unit rate, so k would equal 4/3. And find the value of x in each figure. So if we know that the total of all of our degrees have to be 180, so if I take 180 minus 63, 180 minus 63. Well, first, I'd want to add those up first. 63 plus 86. So this plus this is 149. Then I'm going to want to subtract that from 180. 180 minus 149. I'll get 31. And then I know that this angle right here has to be 180. So then I can take 180 and subtract 31. And I get x equals 149. All right, here we have 3x plus 2x, and then we have 100. So we know that this whole thing has to equal 180. So that would leave this being 80. So if we know that 3x plus 2x equals 5x, and then we know plus 80 has to equal 180. So we're going to subtract 80, get 100 equals 5x, and then divide both sides by 5, and we'll be left with x equals 20. All right, and that will do it for this review.